Hello guys, this is Nadeem from MathsTV. Hope you will like this video. Before starting, I just wanted to invite you to be a part of our YouTube family. You can do this by just clicking the red subscribe button. Also press the bell icon so that you get notifications for newly released videos. And do not forget to follow us on LinkedIn, Facebook and Instagram. Without wasting your time, let us start. Hello guys, today we'll be going through Cambridge International AS and A Level Mathematics Paper 4 Mechanics 970942 Feb March 2020. Question number 1. A lorry of mass 16000 kg is traveling along a straight horizontal road. The engine of the lorry is working at constant power. The work done by the driving force is in 10 seconds is provided, which is this one. Find the power of the lorry's engine. Mass is provided. Mass will be equal to 16000 kg, and in 10 seconds, 10 seconds, work done will be basically the driving force, which is provided, which is 750000, this one, joules, and power we have to find, and we know power is equal to work done over time. This will be equal to 75 and this one divided by time, which is 10 seconds. So this will be equal to, power will be 75000 watts, and we can write this one as answer, or it can be 75 kilowatts. So this will be our final answer. B part, there is a constant resistance force acting on the lorry of magnitude this one. Find the acceleration of the lorry at an instant when its speed is 25 meters per second. So force of resistance is provided. This is the force of resistance. So we can write force of resistance is equal to 2400 newtons, and acceleration basically we have to find, and we know by Newton's second law F is equal to ma, and basically F is what? I'll move the page a little above. So F is basically force is equal to driving force and minus force of resistance. So this is basically equal to ma, and driving force we can write, this is basically power over velocity, and minus resistive force, and resistive force will be 2400 is equal to mass, which is 16000, and acceleration which we have to find. So power which we have already calculated in the previous part, we will utilize that result, 75000 divided by the velocity, which is 25 meters per second, and minus this one 2400. We have replaced these two values over here and we got this, and this will be equal to this one. We will divide this side by this and we will get this A value. Now we have to find this one. To calculate this, A will be equal to, we can use calculator, and for this one we can write 75000. Basically I'll start with the bracket, or otherwise also we can start this one, and divided by 25 and minus 24000, and this will be divided by 16000, and this is basically minus 1 point, this one, there is a calculation mistake. We can redo the calculation. So it will be 75000 divided by 25, which is 3000. So 3000 minus 2400, this will be 600. So 600 divided by 16000, this is equal to 0.037. Calculations we will have to do carefully. So this will be the acceleration, which is meter per second square. This will be our final answer. This is question 1. A and B part is done. Now question 2. A particle P of mass 0.4 kilogram is on a rough horizontal floor. So we can draw diagram for this one, and we can side by side be drawing also. So this is basically the rough horizontal floor which we can consider, and there is a particle P. We can consider this as particle P which is on the floor. So this is our particle P, and mass is basically 0.m is equal to 0.4 kg. This one is the mass. Then the coefficient of friction between P and the floor is mu. So coefficient of friction is equal to mu. We can write coefficient of friction is equal to mu. This is the given information. A force of magnitude 3 Newton is applied to P upwards at an angle of alpha. So above the horizontal. So this will be the P force which is being applied, and this is the horizontal which we can show with the dotted line, and this one is angle alpha. Hopefully you are understanding everything. Now this is the force of 3 Newton. So this is 3 Newton force which is applied to this direction, and this is angle alpha, and this is point P, where tan alpha is equal to 3/4. So tan alpha is equal to 3/4. This is also the information provided. The particle is initially at rest and accelerates at 2 meter per second square. So acceleration is also provided. Acceleration is equal to 2 meter per second square. Find the time it takes. So time we have to find for P to travel a distance of this many meters for its straight starting point. So from its starting point, this distance is covered. So we will apply the equation of motion. S is equal to ut plus half at square. This will be our equation of motion. So S is basically 1.44 is equal to, this will be 0 because initially it is at rest, and plus half into A is 2 and t square, and this implies t is equal to, this will be cancelled, so t square is equal to this one, so t is equal to root of 1.44, and this implies t is equal to, we can check the root, which is root of 1.44, and this will be equal to 1.2. So 1.2 seconds, this will be answer. And for B part, we have to find the value of mu also. To find value of mu, we can consider this triangle, and I will complete this triangle. So in this triangle, this is basically tan theta they have provided. Tan will be opposite over adjacent, so this is tan is 3/4, so this side is 3, this side is 4. This is how the information is provided. Now x, this is basically F force, and this is Fy, and this is Fx. So we can write Fx component minus F of friction. So Fx component's direction will be this one. So this is basically Fx and this is Fy. So Fx will be on this side and friction will be on this side. So we will write F of force of friction will be on this direction. So Fx minus force of friction will be, this will be the net force. Net force will be equal to Ma by Newton's law. So Fx is, from this equation, Fx will be 3 cos theta. Basically this will be 3 cos theta. This is 3 force, so cos of alpha, basically angle is alpha, so 3 cos alpha will be Fx value. So we will write 3 cos alpha minus force of friction is equal to mass. Mass is given, which is 0.4, and A is given, which is 2. So we have replaced all the values. Now F we can shift to other side. So this will be force of friction will be equal to 3 cos alpha and 3 cos, this will be 0.8. So 3 cos alpha minus 0.8. We have shifted this to this side and this one to other side. So we can calculate this. 3 cos alpha, 3 cos of alpha, and cos alpha is what? Cos of alpha we can check from this triangle. This is sine, this will be cos. So 4 by 3. So cos alpha will be 4 by 3. So we can write 3 into 4 by 3. This will be basically 4 over 5, not 3. This will be, by Pythagoras theorem, we can find this will be 5, because this will be 4 square plus 3 square. So it will be 25 under root, which will be 5. So we can check this one. Cos of alpha will be 4 of 5, 4 by 5, right? Now minus this value 0.8, and now we can use calculator for this, and this will be 3 into 4 divided by 5 and minus 0.8, and it will give us value 1.6. So force of friction is equal to 1.6 newtons, and we know that force of friction is equal to mu into the normal force, which is N, and normal force will be what? Normal force we can calculate normal force. Normal force will be force acting upward. Force acting upward. This will be the normal force upward. So this will be equal to this, basically this plus this force, which is also upward. This one Fy. This is upward. So these two forces Fy and N, these two forces will be upward, and downward force will be weight, and this one will be acting downward. So these two forces will be added and it will be equal to W, which is this one. So I will write here F, basically this will be N, force upward, N plus Fy is equal to W, and N is equal to W, which is 0.4 into 10, which is 4, and minus f of x, not f of x, Fy basically. So Fy will be y component of this one. So Fy will be what? 3 sine of alpha. So we will write here 3 sine alpha. Now we can calculate this alpha. We have calculated, which is sine alpha. We can check from here. This will be 3 over 5. So we can replace here 4 minus 3 into 3 over 5, and this will be 4 minus 3 into 3 divided by 5, and this will be resulting to 2.2. So N value is equal to 2.2 basically newtons. This will be upward force. So we have calculated this n value here. This value we will be using over here, and this is 1.6, and this is equal to mu into this one. 1.6 we have calculated over here, and 2.2 we have calculated over here. So these two values we will be using. So mu is equal to 1.6 over 2.2, and 1.6 divided by 2.2 is equal to 0.727. So 0.727, this will be the friction, coefficient of friction. Basically value will be equal to 0.727. Now question number 3, the diagram shows vertical cross section of a surface ABC. ABC are 3 points on the cross section. The level of B is h meters. This is h meters height above the level of A. So this height is h meters. The level of C is 0.5 meters below A. So this is below A. A particle of mass 0.2 kg is projected up the slope. So it is projected up the slope from A with the initial speed, which is 5. So initial speed is equal to 5 meters per second. From here, from A point it is starting, and the particle remains in contact with the surface as it travels from A to C. It is traveling from here A to B, then B to C. So it remains in contact with this surface. Given that the particle reaches B with a speed of 3 meters per second, so the velocity over here is equal to 3 meters per second. Now this is the velocity at B, and that there is no resistance force. Find the value of h. We have to find the velocity value of h. Basically what we can do, we can calculate from A to B. This is the first part which we will be discussing in A part. This one we can discuss the change of energy at A and B. It will be basically kinetic energy will be changing to potential energy. So change of kinetic energy we can calculate. So change in kinetic energy will be equal to, this will be change in kinetic energy, this will be equal to half m into change in velocity square. So change in velocity we can calculate. This is half into m. M is the mass which is already provided, which is this one, 0.2. So we will write here 0.2, and change in velocity is basically 3. We'll have to take change of velocity square. So 3, this will be 3 square minus 5 square, square of this one. So v square minus u square. Basically we can write here v square minus u square. To avoid any confusion, we can write here v square minus u square, so that you can understand this will be the difference in the two velocities. So we can calculate this. This will be 0.5. I'm writing this one. So into 0.2 and multiplied by 3 squared minus 5 squared, and this will be given by minus 1.6. So this is equal to minus 1.6 joules. This is basically the change in kinetic energy. So decrease in kinetic energy. This much amount of kinetic energy is decreased when the particle is moving from A to B. So it means this much amount of energy is changing to potential energy, because potential energy at B is increased level. So whatever loss of kinetic energy is equal to gain in gravitational potential energy. So we can write here loss of kinetic energy is equal to gain in gravitational potential energy or potential energy. So this will be potential energy, we can write, is equal to what? mgh, and this will be equal to loss of potential energy, which is 1.6. So we are taking the magnitude of this one, the amount of energy. So this will be the amount of energy gained. So mass is 0.2 and g value is 10 and h we have to find. So this is equal to 1.6, and this will be h is equal to 1.6 divided by 0.2 into 10, and we can calculate this one as 1.6 divided by 0.2 into 10, and this is basically 0.8. so 0.8 meters, this will be the distance h value which we have to calculate for part A. Now in part B, it is given instead that there is a resistance force and that the particle does 3.1 joule of work against the resistance. Now there in A part there was no resistance, but in this B part we have to consider this resistance force as well. From A to C we have to, when the point is the particle is traveling. So, and this much energy is utilized in working against the resistive force. So find the speed of the particle when it reaches to C. So at sea level, at this point, basically at this point we have to find the speed of the particle. So what we can do, we can check the, like for example, change in potential energy, so or gravitational potential energy. This will be equal to change in kinetic energy plus work done also, because work done against the resistance, that is addition part, because there is resistance also. So we can write here 0 point, this will be mgh, so m is this one, g is 10 and h now we have calculated. This is height is basically 0.5, so 0.5 will be height, and kinetic energy will be half into 0.2, the same equation we will be using. This one will be half mv square, so half m, and energy change will be v square minus u square. Now at B it is initially at A, sorry, not at B, it will be 5, so 5 square, and plus the work done which is provided 3.1, we will add here 3.1. Hopefully you understood this equation as well. Explanation for this one, 0.5 is basically the distance which we are taking from here, this much distance. 0.5 is down, so we are considering up to sea level, so C point, this one, so we have taken 0.5 meters. So this will be, if we simplify this, what we can do, we can multiply this one, 0.2 into 10 into 0.5, and this is giving us 1, so this will be 1, and this 3.1 we can shift to this side, minus 3.1 is equal to, we can multiply this one, 0.2 0.5 multiplied by 0.2, this will be 0.1, so 0.1 into v square minus 5 square. So 0.1 we will shift to this side, so 1 minus 3.1 over 0.1, this will be equal to v square, and this plus 20 minus 25 we will shift to this side, so it will be 25 plus this one. So we can calculate this 25 and plus next will be 1 minus 3.1, and divided by 0.1, and this will give us value 4. So v square is equal to 4. This implies v is equal to 2 meters per second. This will be basically the velocity which is required. Question number 4. A cyclist travels along a state road with constant acceleration. He passes through points A, B and C. The cyclist takes 2 seconds to travel along each of the sections A, B, B, C and passes through B with speed of 4.5 meter per second. The distance AB is 4 by 5 of the distance BC. So this is the condition provided. Find the acceleration of the cyclist. For this one we can quickly draw an easier drawing to understand the situation. So we can draw here, this will be like velocity time graph. We will be drawing a rough drawing. It is not to scale, just for your explanation. This side will be taking time in seconds and this side will be velocity in meter per second. So this will be meter per second, and acceleration, so we can take time as, for example, this one 2 and this one 4. So this is basically 2 and this is 4 seconds, and from here we can take this one as 4.5 and this is basically v. So what we can do, up to 2 we are having up to 2 seconds. This information is provided, that is 2 seconds. This is 4.5. so we will join this one. So this will be 4.5, and now we can take for 4 seconds as well. So 4 seconds, it will be roughly like this one. We can draw reference points and it will be, we can join this as over here. Basically we have to take this one a little lower so that our graph will be proper. So what I will do, I will take up to this one, and now we can join this up to this level. So this is basically the rough drawing which we have drawn. Now this is u value, which is the initial velocity, which is not provided, and this is origin, this is A, B. This distance will be basically under this curve. This is basically velocity time graph, and this is AB distance, and this distance is BC. And in case of velocity time graph, we know the area under the curve is distance, right? So this will be the distance. So AB is equal to, by the condition of the question, AB is equal to 4 over 5 of BC, and we can consider this portion, for example this portion, as trapezium. Basically this will be parallel to this one. So A plus B, and height will be this one, which is 2. So we can apply this formula. Area of a trapezium is equal to 1 by 2 into A plus B into H, and this is basically the formula which we will be applying to find areas of these two shapes. Now we will be considering first this AB shape, and we can write area of AB will be what? Area of AB will be 1 by 2 into 1 by 2 into one side is u, so u plus the other side is this much, which is 4.5. So 4.5 multiply by this length, height, which is perpendicular height, which is 2. So this will be area of this trapezium, and by this condition this is equal to 4 by 5 of BC, which is area of this second shape, this one. Now this will be perpendicular height, which is 4 minus 2, which is 2, and A is this height, which is 4.5, and this one is V, and we don't know this length, right? So this height basically. So what we will do, we will write here 1 by 2 of V plus 4.5 into 2. So this is area of the other trapezium. So what we have done, we have taken this area over here and this area over here, and by the questions condition 4 by 5 we have taken over here. Now rest of the things are just simplification. This will be cancelled with this, and this 2 will be cancelled with this one, and you will get 2 here. So it will be u plus 4.5. u plus 4.5 is equal to this one. 2 into 2 will be 4 over 5. So 4 over 5 into V plus 4.5. So this will be the situation. And now what we can do, we can shift basically u, and this one we can shift this to this side and open this one. This will be 4 by 5 will be 4 divided by 5 will be 0.8. So we can write this as 0.8 V, and plus this one will be 4.5 multiplied by 4 over 5. This will be equal to 3.6. So this is 3.6. This 3.6 is 4 by 5 multiplied by 4.5, and this 4.5 we will shift to this side. It will be minus 4.5, and this is how we will be simplifying this one. We can shift to this side. So u minus 0.8 V is equal to 3.6 minus 4.5. This will be giving us minus 0.9. So now this is basically the one equation which we got, and we know that acceleration is basically what? Acceleration, it is provided that acceleration is constant. In the question they have provided the constant acceleration. So we can write A is equal to A from A to B will be equal to change in velocity over time, and change this will be acceleration BC. This will be equal to acceleration of acceleration from B to C. So acceleration from A to B is equal to acceleration from B to C, but we know that acceleration is change of velocity over time. So change of velocity over time in case of A to B is 4.5 minus u over 2 minus 0. So this one we have taken from here. Change of velocity is happening from 4.5. This is final velocity for this portion. Final velocity minus u divided by this time 2 minus 0. So we have taken from this portion to this portion, and for the other portion for BC, final velocity will be v minus this velocity, which is 4.5. So we will write here v minus 4.5 divided by the difference of time, which is 4 minus 2. So 4 minus 2 we can write over here, and this will be 2. So these denominators will cancel out, and it will be we can write here v plus v plus u or u plus v. We can write u plus v is equal to, this will be this will be shifted to this side, so it will be 4.5 plus 4.5, it will be 9. So this will be the second equation which we will get. So we will be utilizing these two equations. I will be copying these two equations on next page, and we will be solving as simultaneous equations. And I'm copying the first equation, which is u minus 0.8v is equal to minus 0.9, and the second equation just now we got is u plus v is equal to 9. And now we can subtract and change signs. This will be cancelled. This will be 1 minus 1.8v is equal to minus 9.9. Minus will be cancelled, so v will be equal to 9.9 divided by 1.8, and this will be equal to 5.5 meters per second. This will be velocity, and we know from the equation, which is this equation, we can replace this value in any of these two equations. I'm replacing in this equation. So u plus v, which is 5.5, is equal to 9. So u is equal to 9 minus 5.5, which is equal to 4.5. So our answer will be 9 minus 5.5 is equal to 3.5. That's why. So it's not 4.5, it will be 3.5. So we can rectify this as 3.5 meter per second. So this is basically the u value, and u value is over here. So this point is basically 3.5 meter per second. This value at u is 3.5 meter per second. Now the next thing they are asking in B part is find AC, and AC is what? AC is basically the whole distance from A to C that we can check. And for that AC distance, basically we will be checking the complete distance under this trapezium. We can take a bigger trapezium, which is, now we have this V value as well, and V value is 5.5. so this value is 5.5, and this value is 0. So this we have a bigger trapezium now, and we can take this one. Basically A will be our u value, which is 3.5, and B will be 5.5, and height will be 4. So we will find area under the area of the trapezium. So AC will be equal to 1 by 2 into 3.5 plus 5.5 multiplied by 4. So if we simplify this with the calculator, so it will be 0.5 into 3.5 plus 5.5 and multiply by 4 as well. So this will be equal to 18. So this will be 18 meters. Hopefully you understand this part. Now question number 5. Diagram is provided. Coplanar forces of magnitude F Newton, 3 Newton, 6 Newton and 4 Newton act at a point P. So these are the forces acting at point P as shown in the diagram. Given that alpha is equal to 60 degree, this is 60 degree, and that the resultant of the 4 forces in the direction of 3 Newton force. So find F. We have to find F. Now we know what we can do. We can basically split this one, and we know that this will be y component will be upward, this will be Fy, and for this force y component will be acting upward, which will be Fy this side. So these two will be acting vertically upward, and they will be balanced by this 6 Newton force. So if this is this will be what? This will be basically F, this will be equal to F sine of 60 degree. Why 60 degree? Because it is provided that alpha is equal to 60 degree, and this will be 4 sine of 30 degrees. So 4 sine 30 degree, this will be Fy value. So these two values, this one and this one, we will be adding, and we can write sigma Fy, y component of force, is equal to 0. So what we can do, we can write this one. So it will be F sine 60 degrees plus 4 sine 30 degrees is equal to 6. Now F will be equal to what? We will shift this to other side. So it will be F is equal to 6. I think so. I have to move the page. So over here. So 6 minus this one, minus 4 sine 30 degrees, and divided by sine of 60 degrees. So sine of 60 degrees, and this value we can check. This will be 6 minus 4 sine 30 degrees, and your calculator should be on degree mode. So sine of 60 degrees, and this will be equal to values 4.618. So 4.618, and approximately this is equal to 4.62 newtons. So this will be the force which we have calculated. B part, given instead that the four forces are in equilibrium, find the value of F and alpha. So F and alpha we have to find. So sigma Fx, now x component we can check, sigma Fx is equal to 0. So Fx will be what? Again we can refer to the drawing which is over here. So this will be the x component, this will be basically F cos alpha, F cos alpha, this will be acting this side, and this will be F 4 cos basically 30 degree, because this is 4 Newton it is given, so 4 cos 30 degrees. So this force will be acting this side, and this force will be x component on this side. So these two are in opposite sides, and there is another force which is 3 newtons. This force is acting to the right as well. So we'll on right side, these are the two forces, 3 plus F cos alpha, and on the left side it is 4 cos 30 degree. So we'll equate them. We will write here 3 plus F cos alpha, F cos alpha is equal to 4 cos of 30 degrees, and now we can just find the value of basically we can find the value. This is F cos alpha. F cos alpha will be equal to 4 cos 30 degree minus 3, and now what we can do, we can calculate this 4 cos of 30 degrees and minus 3, and this is given as decimal value 0.464. So 0.464. I will be keeping the numbers on the calculator so that we can utilize next. So sigma Fy will also be equal to 0. So y component we can balance. Similarly, we can write equation for y component, F sine alpha plus 4 sine of 30 degree. This is equal to 6. Again, we can refer to the equation diagram, which is this one. So upward force, now we don't know the alpha, so this will be upward, this will also be upward, and downward will be 6. So these two will be equal to 6, because this force is not having any y component. We are not taking this force. Now this one we can simplify, and F sine alpha is equal to 6 minus 4 sine of 30 degree, and this one we can calculate. Okay, so we will calculate this 6 minus 4 sine of 30 degrees, and this will be equal to 4. So this one is 4. So we got this value and this value. Now we can find the angle. For angle direction, we are taking tan alpha. So tan alpha will be sine alpha over cos alpha. So this equation divided by this equation. So f sine alpha over f cos alpha will be equal to 4, basically this one, 4 divided by this. So 4 divided by 0.464, and f will be cancelled. So tan alpha, I'll have to move the page, I'm forgetting again and again. So this one, so tan alpha will be equal to 4 over 0.464. So alpha will be equal to tan inverse of 4 divided by 0.464, and we can check shift tan of 4 divided by 0.464, and this is equal to 83.38. So 83.38, which is approximately equal to 83.4 degrees. Now we got this alpha. Now f sine alpha, we can find the value of f, which is by this f sine alpha. We know this is equal to 4, and this is the equation, which is this one. So we are replacing in this equation angle. So f will be equal to 4 divided by sine of this 83.4, and this will be equal to 4 divided by sine of 83.4, and this gives us error. So we'll have to check. We are not putting maybe this brackets, that's why. And this one, 4.026, 4.026, which is approximately equal to 4.03 newtons. This will be our answer. So this question is also done. Now question number 6. On a straight horizontal test track, driverless vehicles with no passengers are being tested. A car of mass 1600 kilogram is towing a trailer of mass 700. So trailer's mass is 700 kg along the track. The brakes are applied, resulting in a deceleration of 12 meter per second square. The braking force acts on the car only. The addition to the brakes, in addition to the braking force, there are constant resistance forces of 600 Newton on the car and 200 Newton on the trailer. So find magnitude force in the towing bar. So we can draw a simple drawing for that one. So this will be like, for example, over here, this will be the horizontal track, and first I will just indicate, like for example, car is over here. So this is, for example, car, and this is towed with a trailer. So this one is smaller drawing for the trailer. So this is indication for trailer, and this is this is having mass m of 700 kg, and this is having mass of 1600 kg. This is all information provided in the question. Now acceleration is what? Acceleration is 12, which is meter per second square, and this acceleration is to the left because the car is moving to the right, and this force is acting on it, which is F force, and plus there is a force of friction in the trailer. So force of resistance, I will write here, force of resistance is 200 Newton, and for car force of resistance is equal to 600 Newton, and these two forces are basically acting to the left. So these are the three forces acting to the left, These are basically two forces acting to the left. This is a retardation or negative acceleration. So net force, if we have to calculate the net force, it will be F minus 200. We are applying Newton's law. So F minus 200 for this case will be equal to what? 700 mass m into a, and acceleration is what? Acceleration is minus 12. So we can just calculate F will be equal to 700 multiplied by minus 12. This will give us minus 8400 and plus this 200. So plus 200, this will be equal to minus 8200. So minus 8200, this will be Newton's force. This will be acting to the left. So magnitude of the force will be what? Magnitude of the force will be equal to, we'll drop the sign, so 8200 newtons to the left. So this will be the force. Now the next case, is find the braking force. So for the braking force, FB will be what? FB, and there will be two resistive forces which are 200 Newton and 600 Newton. So we'll subtract minus 200 and minus 600 will be equal to MA, and now collective mass of both trailer and car is what? 700 plus 1600 into acceleration, which is minus 12. Now we can simplify this. This will be FB, I'll have to change the pencil. So FB minus 800 will be equal to this one. We can simplify. This will be 700 plus 1600. This will be equal to this one, and multiply by minus 12, and this will be minus 27,600. So minus 27,600, and this will be plus. So FB will be equal to minus 27600 and plus 800, and this will be equal to plus 800. This is equal to 26800 with minus sign. So minus 26800. Now braking force, magnitude of the braking force will be equal to magnitude we will take, so 26800 and newtons, and this will be to the left in this direction. Now at the instant when the brakes are applied, the car has speed of 22 meters per second. At the instant the car is 17.5 meters away from a stationary van. So van is stationary, which is directly in front of the car. Show that the car hits the van at a speed of this one. So initial velocity is provided, which is u is equal to 22 meters per second, and plus distance is provided 17.5, so s is equal to 17.5 meters. Then acceleration is what? Acceleration is same, which is minus 12 meter per second square, which we are utilizing from the beginning of this question. So velocity, we have to calculate final velocity, which we have to calculate, and we can use the equation. I'll move this page, and v square is equal to equation of motion, v square is equal to u square plus 2as, and v square we have to calculate. U is basically 22, this will be squared, plus 2 into acceleration is minus 12, and s is 17.5. Now we can calculate. 22 squared is basically 484. So 484, and this will be minus 2 into 12 into 17.5, and this will be giving us 420. So this will be equal to 484 minus 420. This will be 64. So v square is 64. So v will be equal to 64 root, and this will be taking positive value. So 8 meter per second. This will be the velocity. Now after the collision, the van starts to move with the speed of this one, and the car and trailer continue moving in the same direction with speed 2 meters per second. Find the mass of the van. So law of momentum we have to apply basically. So mass of car and trailer we can take as m1. So u1 m1 u1 m2 u2 will be equal to m1 v1 plus m2 v2. So this is basically, for your clarification, this is car plus trailer, this one, and this is basically van, and in this situation this is car after collision, car plus trailer, and this is van. So this is mass and velocity of car and trailer before collision, and this is mass and velocity of van, which is basically 0. So this factor will be 0. So this factor will be 0, and this will be m1, mass of the car and trailer is 2300 collective mass, and into u1, which is 8. So we will write here 8 and we'll put brackets, and this will be equal to what? This will be mass, and this one will remain 2300, and velocity will be, which is provided 2 meter per second. So 2 meter per second, and this is van is velocity of the van is this one 5, and mass we don't know, so we'll put brackets. So m2 we have to find. Now what we can do, we can multiply, basically simplification only, 2300 into 8. This will be resulting into 18400, and this one will be minus 4600, and this will be equal to m2, and this 5 I'm shifting over here as denominator, and now we can calculate this. It will be 18400 minus 4600 and divided by 5, and this is resulting to 2760. So m2 is equal to 2760 kilogram. This is the mass of the van which we have calculated. Now question number 7, I think so, this is the last question of this paper. So a particle moves in a straight line to the point O. The displacement of the particle from O at time t second is s meters. So this is the equation if this is the range from 0 to 6, and if t is greater than 6, then this will be the equation for the distance. Now find the value of t. We have to find the value of t in first part when the particle is instantaneously at rest during the first 6 seconds. So it means that value of t is less than equal to 6. It's not more than 6, right? So velocity will be equal to what? Velocity, you know, is ds over dt. We are taking derivative of distance with respect to t, and if we take derivative, we'll be using this first equation because this is including greater than also. So we'll be using this equation, and derivative of this equation is 2t minus 3. So 2t minus 3 with the range we can write here t is less than equal to 6, and then v will be, we know this is what do you call, it is at rest, right? So gradient will be, velocity will be equal to 0, velocity will be 0. Why? Because it is at rest. So we will put 2t minus 3 is equal to 0. This implies 2t is equal to 3. So t is equal to 3 by 2, which is equal to 1.5 seconds. So this will be our answer. Now B part is saying at t is equal to 6, the particle hits a barrier at point P and rebounds. Find the velocity. So velocity we have to calculate with which the particle arrives at P, and also the velocity with which the particle leaves P. So this will be basically we know V is equal to what? V is equal to 2t minus 3. This is what we have calculated in the previous section. This one, V is equal to 2t minus 3. And then this one, at t is equal to 6. What we can do? We can replace here. At t is equal to 6, it will be V will be equal to 2 into 6 minus 3, which is equal to 12 minus 3. So it will be 9 meter per second. Now when t is greater than, if it is like t is greater than equal to 6, then what will be the situation? We have to use this distance, the second equation, 24 over t minus t square over 4 plus 25. So this is in case of this t greater than equal to 6. Now we can find V. V will be equal to what? ds over dt. So we'll have to take derivative of this. This will be taken as numerator, power minus 1. So minus 24 over it will be t square. Hopefully you are well versed with the derivative part. So this is this will be 2t over 4. So this will be the derivative, and we can derivative of constant will be 0. And now we can rewrite this one as minus, basically we can cancel 2 2s are 4, and this will be minus 24 over t square minus t over 2. Now this is our velocity if it is greater than this. Now we can replace at the value 6. So V will be equal to minus 24 over 6 squared and minus 6 over 2, and this is the value which we will be simplifying with the calculator. So minus 24 over 36, which is 6 square, and minus 6 divided by 2, and answer will be minus 3.66 recurring. So minus 3.66, and this is approximately equal to minus 3.67 meter per second. This will be the velocity. Now C part of this question, find the total distance traveled by the particle in the first 10 seconds of its motion. So we have to consider the 10-second portion from 0 to 10 seconds. This is the portion which we have to consider, and we have to take integral from 0 to 1.5, and this will be the integral which we have to take dt, and plus from 1.5 to 6v dt. So we'll have to integrate this one, and this will be 0 to 1.5, and velocity for this section is 2t minus 3 and dt, and for this section velocity is 1.5 to 6. Velocity will be 2t minus 3, integral will be this one. So we're basically integrating this portion. This is less than equal to 3. So for less than equal to 3, we have basically done this part. Velocity for this one is this, we have done this. V is equal to 2t minus 3, basically the first step which we did over here, this one. For less than equal to 6, this is the velocity, and the same result we are using over here in this C part as well. Now this will be integral of this will be 2t squared divided by 2, so it will be t squared minus 3t. This will be integral, and we will be writing the limits 0 to 1.5, and plus this will be t squared for this one and minus 3t, and limit will be 1.5 to 6. Now we have to replace the limits. So if we replace the upper limit, this will be 1.5 squared minus 3 into 1.5. Lower limit will be 0, so I'm ignoring that one. So plus this will be 6 squared. So 6 squared minus 3 into 6, this will be upper limit, and minus lower limit will be 1.5. 1 second, I'll move the page. Yes. So this will be this one. I have replaced the upper limit, and lower limit will be 0. Now again limit 6 I have replaced upper limit, and minus lower limit will be 1.5 squared minus 3 into 1.5, and there should be a bracket over here because of this minus sign, and we will close this. Now we have to simplify this. So if we simplify, this is 1.5 squared minus 3 into 1.5, and this will be equal to minus 2.25 is this portion which I've done, and plus I'll maintain the brackets. This will be 36 minus 18, so this portion will be 18 minus this one will be I'm solving this inner portion, 1.5 squared minus 3 into 1.5. This one will be equal to minus 9.4 or minus 2.25, and this minus will be multiplied by this, and it will be plus 2.25. and now we have to add this one. So minus 2.25 plus this will be 18 plus 2.25, basically 2.25, and this will be equal to 18. Basically this will be cancelled with this, so answer will be 18. Now this is the 18 answer which we got. Now this is basically we have done a mistake. Basically over here we have to take the mod. Basically the positive value we will be taking for this portion. This one we'll have to take the positive value, and mod of these both values, basically we have to take positive values, and positive values, this means instead of subtracting, it will be a plus, so 2.25 plus 18 plus 2.25, and this will be resulting to 22.5. so this will be 22.5 meters. So meters, this one, because this is distance, so we are taking positive value. It's not displacement, it's distance, so we are taking only absolute values. So this will be to 22.5 meters from this is from 0 to 6. Sorry, I have written 0 to 10. Why, I don't know. So this is 0 to 6. We are taking limit from 0 to 6, 0 to 1.5, 1.5 to 6. So this calculation is all for from time 0 to 6, and next calculation we'll be doing for 6 to 10. So 6 to 10 seconds, this will be the calculation. Now we'll be taking integral of 6 to 10, and we will be taking the other equation, minus 24 over t square minus 1 by 2t and dt. I'll show you the equation which we are taking. This is the second equation. This one, basically this is the equation which we are taking, minus 24 over t square minus t by 2. This one, this equation we are utilizing over here. So this is from 6 to 10 which we have taken. So this will be integration of this one will be directly, this is basically also we have integrated this part as well, which is 24 over, we can write 24 over t, 24 over t minus t square over 4, this value. Now the question is from where we got this. This is basically, if we integrate this, we'll get the distance, and distance is this equation which we are provided for t is greater than 6. So we have taken this one and we ignored this 25 because this is a definite integral which we are doing. So we will not be taking the constant value, we will be taking only this part. So I have written this part only over here. So directly we can take this and with the limits from 6 to 10. So this is what, and we for your clarification I will be writing definite integral, so no constant included. So we have not included the constant for this. Now we can replace the upper and lower limits. Upper limit, if we are replacing, it will be 24 over 10 minus t square will be 100 over 4, this one, and if we replace the lower limit, it will be 24 over 6 minus this will be 36 over 4, and we can simplify, and if we simplify, I'll try to simplify in one go. So this will be over 10 and minus this will be 100 divided by 4 and bracket close, minus again bracket, this will be 24 divided by 6, 24 over 6, and minus 36 over 4 and bracket close, and this will be equal to minus 17.6. So minus 17.6 is the value which we got, and this is basically meters, this is distance, right? So the total distance will be what? Total distance will be equal to this distance plus this distance. So it will be 22.5 plus 17.6, and this is equal to I'm taking plus because absolute value we will be taking, right? So I'll write down absolute value. So absolute value is equal to 17.6 meters, this one. Now this is 22.5 plus 17.6, this will be resulting to 40.1. So 40.1 meters, this will be the total distance. Hopefully you understood each and everything of this paper, and I'm sure that you will be pressing the bell icon and liking the video as well, and you will be getting intimation for incoming videos. And if you have not yet subscribed, subscribe MathsTV, introduce this channel to your friends and class fellows, also introduce this channel to your respected teachers. Thank you very much for watching the video. Take care. Bye.